All right, so in order to find the area of a trapezoid, a rhombus, or a kite, you have to know what it looks like so you know which formula to use. So just small crash course. What does a trapezoid look like?
It's basically two triangles at the end of the square.
Basically, two triangles at the end of the square. That's a pretty good description. Whoa. Something like that. Okay? So, that is defined as a shape with one pair of parallel sides. Only one pair of parallel sides. So any shape that has one set of parallel sides is considered a trapezoid. So notice that this side and this side are parallel to each other. That is our trapezoid. What does a rhombus look like?
Basically tilted square.
It's like a diamond. It's like a tilted square. Okay, not to be confused with a parallelogram. For a rhombus, it has 1, 2, 3, 4 sides that are congruent. And then what does a kite look like?
It looks like two triangles stuck together.
It's like two triangles stuck together. Kind of like that. It's a kite. So we'll start with trapezoid first. We'll talk about rhombus for a little bit. We'll talk about kite for a little bit. And then we'll be good to go. So here's our first one. Homeboy, trapezoid. A trapezoid is, define the area, 1/2 base 1 plus base 2 times the height. Now, h is the length of the altitude. And remember yesterday, we were not very successful with that term, altitude. So today, I'm going to ask you guys to remember that h is the distance between the parallel lines. H is the height, the distance between parallel lines, or the distance between the bases. So h would be that length, the distance between the parallel lines. Now, base 1 and base 2 are the lengths of the two parallel sides. So if this side and this side are parallel, this is a base, and this is a base. It does not matter which one is base 1 or which one is base 2. You have two of them. You just add them together. Really encourage you guys to use a calculator today. It's just going to make everything so much faster, which will give you a better chance of finishing the whole test in time. Okay? So let's talk about this pink trapezoid that I've just drawn. Let's actually make some numbers. I don't know, 2, 6, and 3. Let's find the area of that trapezoid. So
1/2
area equals 1/2.
base 6.
One base plus the other base
Times 3.
times the height. So if we're using our calculator, we type in, and I'm going to type it in kind of weird because it's just faster. I'm going to do 1/2 and then parentheses base 1 plus base 2 close parentheses times the height, which was, oh, sorry, that should be a 2. Right? That look good? Boom! 12. The area of that shape is 12. So you type it in exactly the way you see it. 1/2, and I used 0.5. It says times 6 plus 2 times 3. That's how you find the area. Nothing super terrible. Just make sure you're using the correct numbers in the correct location. So here we go. It says find the area of the trapezoid. And I'm going to scratch this out. I'm just asking you guys to find the area of the trapezoid and give me to the nearest tenth, 1 decimal place. So if we're finding the area of this trapezoid, the area is 1/2 base 1 plus base 2 times the height. Do we have everything that we need?
Yes.
Okay, so let's fill out our formula. The length of base 1.
5
5 plus 8 times 3. So you would type that in your calculator and you would get an answer. Now if you're a controlled divide person, you could type it in like this. 5 plus 3 times 3 divided by 2. That's. Let's see what happens. Let me type it in. 1/2, 5, 8, and 3. 1/2 times base 1 plus base 2. 5 plus 8 times 3. 19.5. So what is the area of that shape?
5 inches squared.
Yes, John. Because our unit is inches, we have to write 19.5 inches squared. How do you feel? Okay? Trying to make you guys pros at this. Alright, so in this scenario, we're going to ask you guys to do a little bit more geometry to find the whole answer. So if we're doing the area of this shape is equal to 1/2 base 1 plus base 2 times the height. Do we have all the information that we need?
No.
Let's fill out what we have. How big is one base? 10. How big is the other base?
Don't know.
We don't know yet. But how tall is it, or what is the height?
5.
5. So we have to go kind of math and find that other base length. Now, because this is 45 degrees, it creates a 45, 45, 90 right triangle. And it says that this length is 5. So we should be able to math around and say that this length is 5. Same thing goes for the triangle on the left side.
So it'll be 20.
This is 5, so this maths around, and this number is 5. It gives us those isosceles right triangles where the legs are equal to each other. And then you drop the 10 down, which means the whole base is 20. We got lag. So now we have 1/2 times 10 plus 20 times 5. I'm going to do this in my head. I think it's 75. Come on, computer, you can do it. Do that in my head, am I right?
75.
Yes, nailed it. 75 square meters. If you type in 1/2 times 10 plus 20 times 5, it should give you 75. Yeah? So just a little bit of extra math over here to make you guys earn it. Tomorrow on your homework, all the information is already there. You just have to put the right numbers in the right spot. So it makes it a little easier. So now I'm your homework helper. I'm putting all the right information where it's supposed to go. And it's just your job to figure it out. So, do we have all the information that we need? We have a base right here. What else do we have? Where?
We don't have that number.
Do we have a distance between the bases? So we're missing our height right here. We don't know what that is. Come on. Do we know how long this one is? No. So we're going to have to math around and find those numbers. Well, right here is a 30, 60, 90 right triangle. So if this is where the 30-degree angle is, this is my one side, this is my hypotenuse, and this is the square root of 3. So 1, 2, square root of 3. To go from the 20 side to the 1 side, or from the 2 to the 1, you divide by 2. That means that their height is 10. And to go from your short leg to your long leg, you multiply by the square root of 3. So this distance right here is 10 square roots of 3. Right? The whole top is 24. But this one piece right here is 10 square roots of 3. So I should be able to figure out how long this piece is. And I'm just going to do that by doing 24 minus that 10 square roots of 3 number. Let's call it 6.7. Are you cool with that? So I have just discovered that this length is 6.7. So how big is this length?
6.7.
6.7. I also discovered that this length is 10. So how big is h?
10.
Now I have all the information I need to solve for the area. The area is equal to 1/2, 1 base,
6.7.
6.7, that's this side right here, plus the other base, no, the whole thing,
Oh.
24, y'all see that, where the 24 is? The whole top is 24, that was the original problem. So this piece is 6.7, this whole piece is 24. And how tall is it from here to here?
10.
10. So if I math this in my calculator, it should give me the area of the trapezoid.
Didn't get again.
Not this time. 1/2 times base 1
6.7
plus base 2
24.
times the height,
10.
153.5. Now, if you wanted to, because you're extra, like Baker, you could find the area of this square right here, or rectangle, and you could find the area of a triangle, and you could add them together, if you wanted to.
That's extra.
A lot of extra work, but it still works, just so you know that you have options. Okay, new shape. This is for rhombuses or kites. Either one, same formula. Hooray. One formula, two shapes. It is 1/2 diagonal 1 times diagonal 2. It is half the product of the diagonals. Diagonal 1 and diagonal 2 are the lengths of the diagonals. Remember that diagonals go from vertex to vertex. Diagonals bisect each other and intersect at a 90-degree angle. And this is for rhombuses. Okay, so in a rhombus, the diagonals cut each other in half, and they create a 90-degree angle. So now we'll look at the two things. We'll do rhombus first, and then we'll go back and look at kites, and then we'll be done. Super excited.
Yay.
Okay, so we got a rhombus here. Remember, rhombuses, the diagonals cut each other in half. So if this little piece is 13.5, how long is this little piece?
13.5.
Same thing. Now, if this piece is 15, how long is this piece? 15. So to use our equation, how long is this whole diagonal? 13.5 and 13.5. 27. How long is this whole diagonal? 30. So if I do 1/2 of 27 times 30, it gives you the area of that shape. 405. If you don't like that, if that's just too complicated, you can find the area of this triangle, and you can add it to the area of this triangle, and you can add it to the area of this triangle, and you can add it to the area of this triangle. If you wanted to. Yeah? No? Just me? Or you can find the area of this triangle and add it to the area of this triangle. Cool? Yeah? Or maybe you can find the area of this triangle and add it to the area of this triangle.
It's the same.
And it's all going to wind up at 405. If you're a triangle person,
No.
you can do that. You think Baker's a triangle person?
Yes.
Not today, he's not.
Yes, he
Because
is.
I have the diagonal formula. Cool, right? Oh, God, so cool, Baker. All right. Oh, here we go. All right, so we have, look, how long is this?
3.
So how long is this?
3, so that makes it 6.
So one of my diagonals is 6. Now I have to math the length of the other diagonal. So I got a little triangle, homeboy triangle right here. Looks like this. Just going to draw them a little bigger for you guys. Remember that diagonals are perpendicular. So this is 90 degrees, which makes this 30 degrees. Right now I know this number is 3. So I'm really looking for this number right here. That would be half the length of my other diagonal. So you always start at the 30-degree angle.
That'll be X.
1, hypot 2 nus, and the square root of 3. So to go from the short leg to the long leg, or to go from the 1 to the square root of 3, you multiply by the square root of 3. So that means my other diagonal is 3 square roots of 3. Let's call it 3 watermelons right now. Does y'all know what the square root of 3 is? No. You know what watermelon is, right?
Yes.
If you have 3 watermelons over here, and you add 3 watermelons over here, how many watermelons do you have total?
6.
6. So that's the same thing as saying 3 square roots of 3, and 3 square roots of 3 is 6 square roots of 3. So that means my other diagonal
6.
is 6 square roots of 3.
Yay.
So I'm ready to go. I have 2 diagonals. I have a formula to find the area of that rhombus. 1/2 diagonal 1 times diagonal 2, and it gives me the area. I'm going to type that in my calculator because I'm scared of it. 1/2 times 6 times 6 square roots of 3. 31.17, aka 18 square roots of 3. Both answers work, whichever answer you like more. Most of you guys will go to the decimal answer, 31.2. Centimeters squared, because it is an area. You can also find the area of all the individual triangles and add them together, or these 2 triangles and those 2 triangles, or those 2 triangles and these 2 triangles, however you want to do it.
Time for kites.
Oh, hey look, it's the last shape. Homeboy, my kite. So, kites are a little different. They have 1, 2, 3, 4 triangles, or you could do top and bottom triangle, however you want to do it, or left side triangle and right side triangle, whatever you wanted. I prefer to just use the formula, 1/2 diagonal 1 times diagonal 2. So how long is this diagonal? 16. How long is this diagonal? 18. So you just do 1/2 of 16 times 18. Boom, 144.
144 feet squared.
Some high level stuff here, huh? Feel good about it?
Yep.
Alright, so now I'm going to mix it up. I'm going to throw all the shapes at you at once. I'm going to let you guys figure out what formula to use and how to. Oh, never mind. One more. One more kite. How long is this diagonal?
So far, we only know. Oh, wait.
9.5 yards. And then we have to math a little bit in this triangle right here to find that length. Whatever that length is, this length will be the exact same thing. Okay? So I have a triangle, it looks like this. 30, 90, and 60, and it says that this is 2.5. 1, I put 2 noose in the square root of 3. So do I care about this length over here?
No.
I need to go this way. To go from 1 to the square root of 3, you multiply by the square root of 3. So you get 2.5 square roots of 3. Or you have 2.5 tacos on one side, and you have 2.5 tacos on the other side. How many tacos do you have total? 5 tacos, and 5 aka square root of 3. That gives us my 2 diagonal lengths. We have 9.5 and 5 square roots of 3. We need to put that in our calculator and solve for the area. .5 times 9.5 times 5 square roots of 3. We get 41.1 yards squared. Oops. Welcome to the last 9 weeks where everything is just plug and chug. Plug and chug. Use the formula, plug in numbers. So a little bit of student input here. Uh-oh. You have to figure out what the shape is and what formula to use. So if that is a trapezoid, what is the formula to solve for the area of the trapezoid?
1/2 parentheses base 1 plus base 2 parentheses height and height.
So identify the correct formula and plug in everything you need. 1/2. How long is your first base?
7.
How long is your second base?
10.
And how tall is the trapezoid? Uh-oh. So in this scenario, you have to look at this little bitty right triangle right here.
Just add those 2 things and then get your side.
And you have to do a squared plus b squared equals c squared to find b. So you have a squared plus, b squared equals c squared. 4 plus b squared equals 36. Subtract 4 from both sides. B squared equals 32. And you have to take the square root of both sides to solve for b. Or 5.7. So all that math, now b is 5.7. I can plug in the last number I need to find the area. So 1/2 of 7 plus 10 times 5.7. Boom. 48.45 or 48.5 is the area of that trapezoid. Inches squared. So a little bit of extra math to find the height of that triangle or height of that trapezoid, whichever one you're looking at. Good stuff. Ooh, is that the last? Just skip one. All right, what about this guy?
Base times height and base times height divided by 2.
So 1/2 of base times base 1 plus base 2 times the height. I have base 1 right here, but I'm looking for base 2 and I'm looking for the height. So you have a 30, 60, 90 right triangle right here. 1 hypotenuse and the square root of 3. So to go from 2 to 1, you divide by 2. 8 divided by 2 is 4. To go from 1 to the square root of 3, you multiply by the square root of 3. So this distance right here is 4 square roots of 3. If I take 15 and I subtract 4 square roots of 3, it'll give me this distance right here that I need, which is also the same distance as the top. So 15 minus 4 square roots of 3 is 8. We'll call it 8. It's a nice pretty number. This length is 8. So how tall is it up here? 8. Do I have everything I need to find the area?
Yes.
Yeah, I do. 1/2 base 1.
8 plus.
Well, the top is 8. How big is the bottom?
15.
How tall is it?
4.
So it's 1/2 of 8 plus 15 times 4. Or 46 meters squared. Is that right?
Yes.
46 meters squared. Last one. We're doing it. Uh-oh. I don't even know what shape that is. I know it's a pentagon, but have we learned that yet?
It's half of a trapezoid.
There are undoubtedly 2 trapezoids here. We got a purple trapezoid right here,
Let's make it orange next one.
and we got a red trapezoid over here. So we're trying to find the area of 2 trapezoids and add them together. Let's go purple first. How big is one base of that purple trapezoid?
28.
How big is the other base of that purple trapezoid?
35. Height is 13.
And the height is 13. So I'm going to math that real quick. 1/2 of 28 plus 35 times the height of 13. 409.5. That is the purple trapezoid.
Do the same thing to the other side.
Same thing for the red trapezoid, just a little bit of different numbers. 1/2 the first base plus the second base
Plus 35.
times the height. One half times the first base plus the second base. I got my parentheses. The first base plus the second base times, what's the height?
48.
48? 28. 840. So if I add those two areas together, it'll give me the area of the whole shape. 1,249.5 millimeters squared is the area of the whole shape. Alright, so tomorrow you guys will walk in, you'll get one paper, it's got 12 questions on it, you'll turn that in to me before you leave, and it's just all practice in class with finding areas. Sound good? Alright!
That was funny.